Renewable energy has become an important area of research over recent decades. A never-ending source of energy that creates no pollutants is indispensable to humanity, especially considering the severe impact of common energy sources to the global climate. Tidal power, the ability to harness the very oceans around us, to control the seas for our own benefit, is a new frontier on the field of renewable energy, and may lead the way to a more sustainable future.
Tides are created by the gravitational pull of the moon and the sun on the water as the earth rotates. According to EnergyPresentation.ca, there are various ways to harness the energy created by them, and we will focus on the two main types. Tidal barrages, dam-like structures that span across the entrance to rivers, bays, or estuaries, are used to harness potential energy created by the tides. They have sluice gates that allow for the waves to move through tunnels and travel from one side of the barrage to the other. When the high tide comes, the gates are closed and the water becomes trapped in a contained area. The sea level of the contained area rises significantly, causing there to be a difference between the sea level trapped by the barrage versus the sea level outside the barrage. This difference is exploited to create energy. When the difference between sea levels is large enough, the gates of the barrage are opened, and the water is funneled through the gates and into the tunnels, where there are turbines. The rush of water turns the turbines and generates electricity.
Another way tidal power is harnessed is by using tidal turbines, turbines that are placed underwater in areas with high tidal movement to capture the energy of the currents. As the water moves through the turbines, they turn and generate electricity. Tidal turbines can be placed together in larger quantities, in which case they form a tidal fence. Compared to most forms of renewable energy, the mechanical efficiency of tidal power generation is much higher, around 80%, making it a logical choice for energy generation.
Well, tidal power really does sound like a good way to generate energy, but does it have any negative impact on the environment?
After considerable amounts of research, we have concluded the negative effects of tidal power, as outlined in the article entitled Tidal Energy on the National Geographic website. One of the things it would likely have impact on is the marine life. The construction and presence of tidal barrages and turbines will interfere with the natural habitat of marine animals by destroying them and disrupting the flow of water. Specifically, tidal turbines may have a more prominent effect on water flow as they are placed directly in fast-moving water. One model of turbines in the Bristol Channel also suggests that the sound generated by turbines will change the pressure in the water and may cause tissue damage in fish. There's also a risk of organisms getting stuck in the turbines, but they have tried to solve this problem by making the blades of the turbines turn slowly and placing screens in front of the turbines to lower the amount of fish able to reach them. The turbines of tidal barrages are fast and do not have this protection, so there is a higher risk of organisms getting caught in them. Organisms may also become trapped in the area closed off by the barrage. The barrage reduces tidal range, and the change in water level caused by the barrage also changes the salinity of the water. This change may harm the organisms that inhabit the area. The altered tidal range may also affect birds that feed in the area, as they may not be able to find food in the new environment and will be forced to migrate. In the long run, the land where the barrage is may be completely disrupted due to the risen water level. But once again, tidal power isn't widely used enough to be completely certain of these effects, so this is just a theory.
So why would we want to use tidal power if it may have such a negative effect on the environment?
Well, even though there are negative environmental effects to tidal power, there are benefits as well, as noted in the article, Tidal Power Advantages and Disadvantages on the Hydro Earth website. Tidal power generation creates almost no carbon, greenhouse gases, or other pollutants, except during the construction of the power plants. Like other renewable forms of energy, tidal power is inexhaustible, and one plant has a very long lifespan. One plant could produce energy for generations to come. Plants are also very predictable, which allows for both predictable energy and an accurate estimate of how much a plant is capable of generating. Water is 1,000 times more dense than air, so unlike wind turbines, tidal turbines can both turn slower and can produce more energy, which is yet another way to help protect organisms from being caught in the blades. Climate change is such a huge concern right now, and tidal power is certainly a type of energy that would benefit us in that area. Of course, there is much to take into consideration when thinking about whether or not tidal power is the right source of power to use. On one hand, the effect of tidal generation in the areas where the plants are constructed may be detrimental to the local organisms. The state of the water in that area will also be changed. The tides and salinity will be altered. However, having such an efficient source of renewable energy is beneficial to humans as a whole. Tidal power will help us lessen our impact on the production of pollutants and will help us slow down global warming.
But Jonathan, don't tidal power stations cost a ton to construct, making them non-viable for the present?
Well, you see, Felicia, you actually have a valid point there. According to the United States Energy Administration, a coal power plant only costs $1.7 billion to produce, as opposed to the astronomical $5.7 billion cost of a tidal plant. It seems almost like a no-brainer that the coal should be the way to go. However, if we're thinking all long-term, tidal is the more effective energy source. This is due to far lower maintenance and running costs compared to its coal counterpart, with energy costing 13 cents per kilowatt hour as opposed to coal's 18 cents per kilowatt hour.
What about research and development, though? Tidal power must have an astronomical cost there, especially compared to coal power, which has been researched longer and is far simpler in concept.
Well, you'd certainly be right there. While we don't have exact numbers, the research and development costs of tidal energy are sure to be much higher than that of coal power. For starters, tidal power is a relatively new form of energy, with the first plant opened in 1966. Coal, on the other hand, has been widely used as an energy source since the Industrial Revolution, and is the most well-entrenched product on the energy market. There's almost no need for additional research, other than figuring out ways to reduce carbon emissions and such. The only way tidal power is even feasible is due to extensive government funding. Well, actually, not anymore, due to companies such as the BlackRock Tidal Power Company and Tidal Stream Limited popping up. But progress is slow going due to the immense research and development costs and costs for initial construction.
What about a location? If it's tidal, it just needs to be in water, right?
Oh no, that's not right at all. Tidal power plants are only optimal where the difference between high and low tide is greater than 7 meters, allowing for a vast amount of water containment and release. For tidal, location is everything. That's another one of tidal's problems. Many areas are suitable for tidal power are simply too far away from civilization to be a feasible endeavor, such as the proposed Penjin Tidal Power Plant project in Russia. There are no significant cities that it could power, so the concept has never been acted upon.
So, to sum it all up, the weaknesses of tidal power is that it is ludicrously expensive to construct, must be built in specific locations, and hasn't even been researched substantially enough, while the strengths are that it pays off in the long run in the form of low running costs and amazing lifespans. As such, the tidal plants are a significant long-term investment that pays itself back and enriches the area surrounding.